All right. Number one, let's do the odds here today, evens tomorrow. Number one is a break-even problem. Okay, you will see one of those on your test Wednesday. Break even. How many desks in this case? How many desks do I need to sell to break even? It is only one equation, one variable when you do the break-even problem. Remember, one equation, one variable. So we set our variable up now. Again, since we're finding desks, if you want to make it D, that's up to you. I'm just going to let X be number of desks. And remember what we talked about. We just said a couple seconds ago. One equation. That's it. That's it. One side of that equation is their costs. Any cost associated with making a desk. And you should usually have two pieces on that left side. Two pieces. One is, hey, it's going to cost me $200 a desk to make. So I have 200 X, right? And then most of the time, all of the time, there's some other cost associated no matter how many desks you end up making. And you see up here, fixed cost $60,000. That means you make one desk or you make 100 desks. It's still going to cost you $60,000 up front. So that's what I need to add into the cost side. So I have $200 a desk to make plus no matter how many desks, $60,000. Notice I didn't attach a variable to it. It doesn't matter how many desks I make. 60 grand. Equal to, all right, on the other side now is your revenue, how much you bring in. And that's the rest of it, which is $450 a desk. So 450 X. A reminder, if it does come out to be a decimal, you cannot sell or make a portion of a desk, so you round up. And that's how many desks it would take to break even. Okay? And you guys can finish that when I'm done talking. Any issues on break even? Because here's the problem, guys. Your test is in 48 hours, and that's the only break even problem I'm going to review with you. There's no more in the packet. All right, so just making sure everybody's good. All right, let's move on. 3. We're going through the odds again. This is going way back in the unit. I couldn't even tell you when we did it. Mixture problem. All right, a mixture problem. So you guys remember mixture problems? I had you guys do the bins here. Show me exactly what you're mixing together, and that hopefully will be easier on you to make up the equations when we're ready. All right, here we go. In bin number 1 there, a 34% solution of silver nitrate. All right, so I put 34% in bin 1. Underneath it, hey, how much do you need of the 34%? I don't know. That's your job to find that. So there's my first variable, X. I don't know how much it is. That's my job to find how much of the 34% I need to mix with. Bin 2, mix it with one that is 4% silver nitrate. How much you need of the 4%, you ask? I don't know. That's your call. That's your deal. Wow. Yep. And that should be the last variable that shows up. These mixture problems only require 2 variables. So in that last one, I should have no variables. Why? Here we go. Mix them both together. You should have a 7% solution of silver nitrate with, there you go, 100 underneath it. 100 milliliters. All right, the picture's great, but I really need the 2 equations you're going to solve. All right, so how can I use this diagram now that I made to figure out my 2 equations? First equation, forget the percents. Forget the percents. Just tell me how much you need total. So, whoa, forget the percents. Forget the percents. I want to know how many milliliters of each you need. X plus Y, and they should all total how much do I need? 100. So there's where you get your first one. Now apply the percents. Now apply it for the second equation. I need 0.34 of this X solution. How do you write 4%? 0.04 times the Y. And this has been driving me nuts, this unit. You guys you do awesome on the left side, but then you totally forget the right side what you've been doing. I did the percent times how much I have. Percent times how much I have. Keep that going. Percent times how much you have. All right, don't just write 100 there. Don't just give me 0.07. That second equation is percent times how much you have, even on the other side of the equal sign. Now, if you want to go to the calculator and change that up and put that as 7, that's fine. All right, to get that out of there, but you do have to multiply your percent, bless you, your percent times how much you have. All good. And then again, you guys can solve this coming up in a couple minutes. So everyone all right with the mixture? I'm going to throw a mixture one on there Wednesday. All right. Number 5, I'm not talking about at all. What's the maximum of this region and what's the minimum? You guys know from before break, I take each of the 4 points, plug it into what's called my objective function, which starts out as z equals. All right, I'm not going to go over. You guys can do that on your own, how to find the max and the min. And I do have, I think the first question on Wednesday's test is that, what's the max value, what produces a max value? All right, at the end of your test on Wednesday, you will have one of these big dog ones, number 7, where you got to do everything from scratch. All right, what's going to give you the maximum amount of profit? So you guys need to give me the z equals, give me your inequalities, graph shade, bring the points off, plug it in, and then tell me what's going to bring a max value. All right, so go ahead, read through the type of paper we have here on number 7, and then we'll go through parts A and B, at least A and B together. All right, so here you go. So let X be the writing paper, and we're going to let Y be the number of newsprint we have. Write in an objective function. Hey, objective, remember, that's Z equals. Okay, Z equals. And it's going to be this easy on Wednesday. The money goes with your Z equals. Okay, the money goes with Z equals, so I can see how much profit I can have. 500 for writing paper. So 500 times X plus 350 for the newsprint. 350 Y. There you go. That's going to tell me what's going to give me the most profit. And remember, I don't do anything. I don't graph it. All I do at the end is I plug in my corner points into there to see which one gives me the max. All right, now I need your help writing the inequalities for me. The equipment can only make at most 200 units of paper. And when I say paper, that's newsprint and writing together. Together, newsprint and writing. At least 200. At least 200 of those to get both of those together. What's your first inequality? X and Y together, right? X and Y together, because when we say paper, it means both. At most. At most. Think about money. You have at most 200. Do you have 200 or less or 200 or more? You have at most 200 bucks in your pocket. You have 200 or less, right? So less than or equal to 200. Can't do any more than 200. All right, next one. Regular customers require at least 10 units of writing paper. Stop there, at least 10 units of writing paper. Well, writing paper is X, right? And 10 units, at least. What symbol am I putting in between there? At least. Greater than, at least 10 or more. Greater than or equal to. And the same thing for newsprint, but it's 80 units. So y greater than or equal to 80. Questions? And then make sure you know your intercepts. This will be a first quadrant graph because there shouldn't have negative amounts of newsprint. You just got to figure out what to go by based on your intercepts. And then remember what's horizontal and vertical. All right? Get your Chromebooks out before I let you go on your own, please. Chromebooks out. Please open up the classroom. Because as you finish each problem, I'd like you to check the answer key. All right, so go to Unit 8 on our classroom page, Unit 8 on our classroom page, and you'll see the answer key. Download it and check your answer every time you finish one. Tomorrow we hit up the evens, which are a lot tougher, but I want to be more fresh in your mind. If you get stuck somewhere, let me know. I'll help you out. I don't need to see it when it's done, though, but you should be checking your answers.